Hey guys, we're continuing with our circles. Today we're going to look at central angles in a circle. So a central angle is an angle whose vertex is the center and whose sides are radii of a circle. So a central angle, here's the center, and then this is just one example. CD is a radius and CE is a radius, so angle DCE would be the central angle there. One thing to know is that the measure of a central angle is equal to the measure of its intercepted arc. So its intercepted arc is the arc that it's opening up to. It's opening up to arc DE. So that means if angle DCE is 45 degrees, then arc DE is also 45 degrees. So we have three different kinds of arcs and ways to classify. So a minor arc is between 0 and 180 degrees. So in this case, arc DE would be a minor arc. We name minor arcs with 2 letters. So DE would be considered a minor arc. It's smaller than 180. AD would also be considered a minor arc. There's lots of them up there. You can come up with more examples. A major arc is bigger than 180 degrees, but smaller than the entire circle, 360 degrees. We name a major arc with 3 letters. So a major arc could be like arc FEB. Notice if you trace around with your finger, if we start at point F, I'm going to follow it around to E and then B. That helps us to distinguish from arc FB would be everything that I don't have highlighted in red there. That would be a minor arc since it's smaller than 180. So naming it with 3 letters helps us to do that. And there are other major arcs, and you can pick more as examples. A semicircle is equal to 180 degrees. We name a semicircle with 3 letters, and again that helps us to distinguish which part of the circle we're talking about. So name with 3 letters. So a semicircle could be like AFB. And there are other options. FDE would be a semicircle. You can pick out some others that you see if you would like. So the arc addition postulate says the measure of an arc formed by 2 adjacent arcs is the sum of the measure of the 2 arcs. So in this case, if we say the measure of arc AB plus the measure of arc BC, that would give us the measure of arc ABC. We just add them together. Alright, these should have arcs above them. I don't know if they have them on your notes, but they're not on mine, so I'm adding them now. You join a new bank and divide your money several ways, as shown in the circle graph at the right. Find the indicated arc measure. So we want the measure of arc BC. So here's arc BC, and I know that my central angle measure is the same as the arc, so it's 140 degrees. Then we need the measure of arc BCD. So I have 140 degrees plus 60 degrees, which is 200 degrees. Okay, so congruent circles have the same radius. Congruent arcs have the same measure and they're arcs of the same circle or of congruent circles. That seems pretty straightforward, but it can get a little tricky. This says tell whether the given arcs are congruent. So we have two arcs that have the same measure and they are inside the same circle. So we can say that yes, they are congruent. However, looking at this one, I have the measure of arc AB and I have the measure of arc CD. While they have the same measure, they're not of the same circle and their radii are different lengths. So their arc lengths are not the same measure. So in this case, we would say no. Alright, for the last one, we have arc FG and arc HJ. We have two congruent circles and they have the same measure. So here we can say, yes, they are congruent. Alright guys, if you have any questions, feel free to come in and see me. If not, I'll see you in class.